Assalamualaikum. My name is Ayesha Akter. Now I'm going to present my presentation whose name is Visual Quotient Generation from Radiology Images, and the writers' names are in this slide. This presentation is designed for Mr. Annajit Alim Rasil sir, who is our Symbolic Machine Learning Part 2 course instructor, and the course code is CC712. Let's start from the next slide. Now abstract. The visual quotient generation, the task of generating a quotient based on image content, is an increasingly important area that combines natural language processing and computer vision. So in this paper, they introduced an approach to generation of visual quotients about radiology images called VQGR. An example that is able to tax a quotient when shown in an image. Now, VQGR first generated new training data from the existing example based on contextual and word embeddings and image augmentation techniques. Then uses that variational autoencoders model to encode image to and latent space and decode natural language quotients. In this paper, the first part, introduction, they introduce VQGR, a VQG system that is able to generate natural language quotients when shown radiology images. Number one, the task. To the best of our knowledge, generating quotient based on image content has not been explored in the medical domain. Number two, in the medical domain, the lack of large sets of level data makes training supervised learning approaches inefficient. To overcome the data limitation of medical VQG, they represent the data augmentation on both image and the quotients. Number three, VQGR is based on the variational autoencoders architecture and design. And the last one, experimental evaluation performed on the VQA-RAD dataset of the clinical quotients. Next part, related work. They represent VQGR, a VQG system capable of generating quotients about radiology images. The system is based on the VAE architecture and the data augmentation. Next, method. So here we can see a figure. That figure, it is first one, it is an image, and that encode the CNN process, and that also encode the Z shape. Also they include the MLP part. Then here the algorithm is happen in below, that is work in the quotients, and the finally the result will be given, that which is abnormally plan or something. It was happen in this sections. Next, in third section 3.1, data augmentation. Here the BQA rate that is contained training data, that means D. Next, visual quotient generation. Equation 1 that contains the probability of distribution data. Next, 2, that is loss function. Third, minimize loss. Fourth, Z space using a sample MLP. Fourth, the predicted word. And finally, the sixth one is final loss of VQGR. And besides, we can see example or figure, that is the main figure, that is the example of test image with the generate quotient shown in the blue and the ground truth. That means the first quotient, third quotient, as well as the next quotient, which is modality used for this image, and the next image is lance species, and the last image is liver normal. The fourth part of this paper, experimental and result. Before we discuss about the data set evaluation matrix perform both automatic and manual evaluation, so now we will get the experimental result. First one, data set. Use the VQA rate, that means RAD data set of clinical visual quotients and image. It contains 315 images and 3,515 corresponding. And the next, particularly interested in quotients about modality, abnormality, organ, and the plan. Next, evaluation matrix perform both automatic and manual evaluation. Number one, automatic evaluation. Number two, human evaluation. Number one, used a variety of language modeling evaluation matrix such as BLEU, ROGUGA, and the METEOR and the CIDER. Second, manually check the generate questions and related rate them in terms of relevancy, also grammatically and the fluency. Number third, implementation details. Used ImageNet retained RSNet 50 provided by PyTorch as the image encoder and not fine-tune its weight. LSTM decoder is used for generating and questions. And the fourth one is result as well as discussion. Here below I have included the three tables that the discussion resulting part. So according to the paper, the last part, conclusion and the future work. First one, a data augmentation method to generate a new training question and image from the VQA-RAD dataset. Next, introduce the VQGR model that generates questions from radiology images. And the future work, they will investigate the use of the generate question to advance VQA in the medical domain. Thank you to all.